Okay, so let's talk about our parent cosine function now. So I'm going to move this back over. Again, we're still talking about our unit circle. We're going to extract now our cosine information and see if we can graph a function for cosine that is in fact a function and not part of a unit circle, which we know is not a function. So I'm going to do the same thing over here as I did with my sine. I'm going to create a unit circle where I'm going to outline again my quadrantal angles, since my quadrantal angles tend to be the easiest for me to graph. And those quadrantal angles again are 0 degrees, 90 degrees, 180 degrees, 270 degrees, and back around again is 360 degrees. Going back off my unit circle, I know that at 0 degrees and 360 I have the ordered pair 1, 0. At 90 degrees I have the ordered pair 0, 1. At 180 degrees I know I have the ordered pair negative 1, 0. And at 270 I have the ordered pair 0, negative 1. 360 again is coterminal with 0 degrees, so they both share the same ordered pair. So again, I'm looking at cosine as my parent function, so I want to pull out just the values at these given degree measures around my unit circle that correlate to cosine. So if I start off with 0 degrees, I know the cosine, which is my first value, at 0 degrees my cosine is 1. If I continue around my unit circle at 90 degrees, I know my cosine is 0, my first value. 180 degrees, my first value, which is cosine, is negative 1. At 270 degrees, my cosine value is the first one, which is 0. And I'm back again around at 360 degrees, one full circle around my unit circle, and I'm looking at a cosine again of 1. Since my unit circle does not pass the function test, the vertical line test, I know I have to create a new graph from this information that will give me a graph of cosine that is a function. So I'm going to use this information that I extracted from my unit circle to create a cosine graph. So when I do that, I create an x-axis, that's my degrees. I create a y-axis, that's my cosine values. Since cosine, my greatest cosine value is 1 and my smallest cosine is negative 1, I know that my cosine graph is going to be between those values. So I know 1 is going to be my highest value, equidistant is going to be negative 1, and I have 5 quadrantal angles. So I'm going to graph those along my x-axis. I've got 0 that starts out at my origin. 90 degrees will be my first quadrantal. Equidistant from that is 180 degrees. If I go a little bit equidistant over again, I get 270 degrees. And equidistant from that is 360 degrees. So from 0 degrees all the way around to 360, in this horizontal line, I'm using values, angle measurements, that represent one full circle around my unit circle. So now I can just take this information from my cosine and I can use them as ordered pairs. So at 0 degrees, my cosine value is 1. At 90 degrees, my cosine value is 0. At 180 degrees, my cosine value is negative 1. At 270 degrees, I get a cosine value of 0. And at 360 degrees, I get a cosine value of 1. So now using my graph for cosine that I graphed here, I can plot these points on this graph, and hopefully we end up with a function not like our unit circle above. So at 0 degrees, I have a cosine value of 1. So that's going to be my starting point, my first value. At 90 degrees, I have a value of 0 for my y. At 180 degrees, I have a value of -1 for cosine. At 270 degrees, I have a value of 0. And at 360 degrees, I have a value of 1. So if I connect the dots here, knowing that my graph does not go higher than 1, I get a graph that looks similar to this, which you can tell is a little bit different than what my sine looks like. And if I take my pen and I run my pen vertically all the way across, I know that it passes my vertical line test. So this is a function, whereas my unit circle from before with my cosine values was not a function. So we extracted the information that I needed so that I could create a graph for cosine that is a function. So if I go back to my parent functions here, where it's given to you as your graph in your Blackboard Assignment 12 should match the graph that we came together and created for this cosine graph. And you can see the similarities and differences between your sine function and your cosine function. So just remember, my sine function and my cosine function, this is what we call our parent function. If you remember, on the other side of the page, our general, let me write this down real quick, our general graphs for these, our general equations, this is not sine, this is cosine, has the a in front of both our sine and cosine and a b value in front of both of our x's. That's our general graph of our general ideas of how we're going to graph our sine and cosine. But the idea is that our parent function has 1 for both a and b for both cosine and sine, so that these guys right here are what we call our parent function, because we have a 1 in front of our sine and a 1 invisibly in front of our x for both of these. So our parent function is going to have the shape and the values that these two graphs have in front of you. In the next video, we're going to talk about these characteristics and build in some information into these graphs so that you have these notes to pull from when we start graphing them together in examples 1 and 2.